forces. Okay. There's the strong force. There's the electromagnetic force. And I'm going to write them in the order of strength. So strong force is the strongest. And then you've got well, I put electromental, electromagnetic. I don't know what I was thinking. Electromagnetic. And that's the next strongest. And what you got to think about there is like magnets and point forces, which I don't know, doesn't mean anything to you. Point charge, not point forces, point charges. What that means is a plus and a negative. Okay, that's what that means. So like in like protons and neutrons, anything that protons and electrons, sorry, anything that has a charge to it. Okay, that's what electromagnetic is. The strong force is the forces in the atom, in the nucleus of the atom. It keeps the nucleus of the atom together, is what it does. What we're going to look at is this one. Okay, and then there's two more forces. The weak force. The weak force is also in the atom. And then we're going to look at the electromagnetic. We're going to dive into the electromagnetic, and we're also going to dive into gravity or gravitational forces. Okay, so you've got four fundamental forces: the strong force, electromagnetic force, weak force, gravity. Okay, all of these are in order of strength. So the weakest is gravity, which doesn't make any sense to us because we think gravity is the strongest because we see gravity everywhere around us. The problem is we just don't see these other forces to understand that they're actually stronger than gravity. So what we're going to do is we're going to look at these two forces right here. We're not going to look at the strong force and the weak force. If we were going to do that, we should have looked at those when we were in chemistry and talking about the atom. So we're going to look at these two forces. So electromagnetic and gravity. So we looked at electromagnetic a little bit last semester when we looked at Coulomb's law. So one of the things under electromagnetic is Coulomb's law. It's not comprehensive. It's not the only thing under electromagnetic, but it's just what we're going to look at. Okay, and that we looked at it when we were in last semester, but we didn't put any numbers to it. This in this lesson you do. So in Coulomb's law, all of these, right, these four forces, they're all forces. So anything that we calculate is a force. So this is Coulomb's law. It's the force of charges. So how much, so when I say charges, a plus and a negative, right? We know that opposites attract. So this is going to be an attractive force. How much are they pulling themselves together? That's a force. A force is a push or a pull. So this is attraction. So it's the force of attraction. All right. That equation is this. And I think it's an r squared, which means radius, but I'm going to put distance because that just makes more sense to us, but it's the same thing. Okay. So this K is a constant, which is great for us, which means it does not change. So that's always going to be the same number, which is great for us because then we don't have to think about what number goes there. It's always the same number. K equals 8.99 E9. So what that E9 means, that's scientific notation. That means 8.99 times 10 to the 9th, which is just a shorter way of writing that. So it's really this number right here. It's just scientists are so lazy, they don't want to write all the zeros. So they write like this, 8.99. They move the decimal from here to there, and that is 9 places. So 9 places. So 8.99, move the decimal, and then the exponent is how many places you moved it. Scientific notation. So it's times 10 to the 9th. Now, in your calculator, this times 10 is represented by this E. So if you ever see that E, it means times 10. Okay? Now, let's go over what the rest of this is. This Q is the amount of charge. One of them, there's going to be 2. And the other Q is the amount of the other charge. So basically 2 objects and 2 different charges. And then D, like I said before, is the radius, which just means it's the distance. Now, part of the problem that people do, they forget about this squared. When you use this equation, you got to square it. All right, so when you have these word problems, take out all the numbers and label them. That's going to help you put them into the equation better. I know it takes more time and you don't want to do it, but do it anyway. All right, so here I've already done it. I've taken out all the numbers and I've labeled them. Right, so now all I got to do is put them in here, and that's half the battle. So if you do that right, put all the numbers in the right, use the right equation, put all the numbers in the right place, I'm going to give you most of the credit because putting it into your calculator is a little tricky from here. 8.99 E9, that's K, so that's K, times Q, and so the first Q is this. Actually, both Q's are this, 1.85 E negative 18. So really, this E negative 18, what that is, that's also scientific notation. But negative 18, so this is a really small number. So there was 0, 9, 10, 11, 12, 13, 14, 15, 16, 17, 185. So it's actually that number, but who wants to write all these zeros, right? So it's a really, so when you have a negative exponent, you really have a very small number. All right, so I put that in and I put that in twice because both the charges have the same amount. They don't always, but this one does. Because it's this. All right. And then distance. So 0.025 squared. All right. So if you can get this far, I'm going to give you most of the points. If you show me your work, if you don't, I can't help you. All right. So putting this in your calculator can be a little different. Because you've got to use a function you don't normally use. All right, so putting in your calculator, you would do 8.99, and then you got to do the scientific notation. So in most TI calculators, that's the EE function. So generally the EE function is a second function, and it's right above the 7. So if that's true in your calculator, you would put in 8.99 and then hit your second function and hit EE, and it does this. It's going to put this E out there, and then you put the exponent. So the exponent is 8, right? 9, dang, 9. So that's what it should look like in your calculator if you put it in the right. And then you just keep going. So then we're going to multiply that by 1.85 EE negative 18. Times 1.85 EE negative 18. That's going to give us a number. And then we're going to divide that by the distance, which is 0.025. But we're going to square that first. And if you don't put that in parentheses, it's going to divide and then it's going to square the whole thing. So you really need to put this in parentheses. Point 0.025. And square it. And then in parentheses. All right, I get what I got was 5.47 times 10 to the negative 33. All right, that is how you use Coulomb's equation. And then there's the other equation, the gravitational equation. And it looks very much like the Coulomb's equation. So I said we were going to look at two forces. We looked at electromagnetic, and now we're going to look at gravitational force. The equation for gravitational force. So these are really, every mass attracts every other mass. We don't really know how gravity works. There are separate theories on it, Newton's theory and Einstein's theory, and we don't really know which one's which one actually is right. But we do know, because we've had experiments, that mass attracts mass. So that's what we call gravitational force. And that is dependent on how far away they are. So the farther the distance, the less force. So that equation is this: force of gravity, where up here we had force of charge. Force of gravity is G times mass 1 and mass 2. And that's going to be distance squared. So you see it looks very much like Coulomb's. The only difference is we have masses, and this G is going to be different. The G is 6.67 times 10 to the, let me see what that, negative 11. So if we use this, we're saying that mass 1 and mass 2 are attracting each other. There's a force of attraction, and we're seeing how much that force is. Let's look at a word problem. So again, we take the numbers out. And we just put them into, so this says the Earth and the Sun are 1.5 meters apart, okay? Using Newton's law of universal gravitation, calculate the force of gravity. So Newton's law of universal gravitation is this equation right here. We're just going to see how much force, how much attraction there is between the Earth and the Sun. So using this equation. So we already took out the masses and we already took out the distance, and we just got to put them in our equation. So f of g equals g, which is 6.67, and it's always that because it's a constant, times this mass and this mass, uh, 30. So the mass of the sun is much larger than our mass because it's a much bigger body. It's much bigger celestial body, even though it's only just made up of gas. But isn't that interesting? Yes, it is. Okay. Distance. This is 1.5 squared. So if we took the Earth and we moved it away from the sun, farther from the sun, it would have less force on it. So more distance, less force. More mass, more force. So if mass goes up, force will go up. If distance goes up, because it's underneath, force will go down. Distance up, force down. So put this in our calculator. And it's going to be a really big number. 6.67 EE negative 11 times 6.0 EE 24 times 2. EE 30. Okay, that comes out to be 1.2 EE 55. So really big divided by 1.5 EE 11 squared. So I take that 1.2 EE 55 divided by parentheses 1.5 EE 11 and square that and in my parentheses. And I get a really big number, like I said, 5.33 times 10 to the 32. And that's going to be, what is that going to be? It's not going to be joules. It's going to be newtons. Force is always in newtons. I don't know why I had a problem with that. Force is always in newtons.